In this lesson, we discuss a number of measures used in model evaluation. We will start with the confusion matrix that summarizes the result of the model. Then we will learn how to compute accuracy and error rate. After that, we discuss the issue of class imbalance, which will lead us to a new set of measures like precision, recall, and F1 score. When evaluating a classification model, we typically start with simple accuracy. Think about everything we got right, positive examples and negative examples divided over the total number of examples. But soon enough, we start to realize accuracy has its own limitations. So to get a complete picture of the model, we have to explore more metrics. Suppose we have a binary classification problem like spam versus not spam, medical diagnosis, positive, negative. The confusion matrix is a table that summarizes how well the classifier performs. The rows are going to represent the actual true class, and the columns are going to present the predicted class. Throughout this lesson, we'll keep on going back and forth on this spam detection example and the medical diagnosis. So true positive and true negative are the good thing. The classifier correctly predicted the spam emails and it correctly predicted the non-spam emails. But for false positives and false negatives, the interpretation and the impact depends on the context that we have. In the spam detection problem, false negative is not that bad. What's going to happen if a spam landed in my email? Okay, that's just fine. I'll delete it. But false positive is really bad. Let's say I have this very important email coming from my boss, but it landed in the junk folder. So I'm not going to read it and I will get in trouble. So in this context of spam detection, the false positive seems to be worse than the false negative. But in a medical diagnosis context, the impact of false positive and false negative is different. So a false positive is inconvenient, but a false negative can be very dangerous. So I want you to keep the idea of how to interpret false positive and false negative as we go through these measures. The first measure that we will learn is called accuracy. And in accuracy, we want to find the percentage of test set tuples that are correctly classified. And as you can see in this visualization, we are summing up the true positive and true negative and divide by all. In this example, we work out the accuracy and error rate for the cancer problem. And as you can see that accuracy is high, 96.5%, and the error rate is somehow low, 3.5. Now we want to discuss the class imbalance. In some cases, one class may be rare, such as financial fraud or having a particular disease. So this is going to lead to a significant majority belonging to the negative class, while only a small fraction represents the positive class. So there's a class imbalance here. So if we only paid attention to accuracy, we might report a high accuracy rate, but fail to detect those rare and critical cases. To address the issues of class imbalance, we define additional measures. Sensitivity or recall is the true positive recognition rate. So I'm going to divide the true positive over the all positive. Similarly, specificity is the true negative rate, which is the true negative over the total negative. And here is an enlightening example. So now we can see that this class is not sensitive. So we only detected 30% of the total positive cases, but it has a good specificity, which is 98.56. So whenever it's negative, it was able to detect it with higher specificity, but it's not sensitive. Another point we want to add that looking at sensitivity and specificity in isolation can be misleading because we can have a great specificity but low sensitivity and the other way. And in this example, let's just create a test that always says no. So it's going to have a perfect specificity, but it's going to do very bad in sensitivity. When we use sensitivity and specificity, we need to look at the two numbers together to make a good sense of how the model is performing. Now we add more measures to our toolbox, and precision and recall are measures that came from the information retrieval community. So precision measures how many of the predicted positive cases are actually correct. So we're dividing true positive over the total number of true positive and false positive. In other words, out of everything that the model classified as positive, how many were truly positive? And here's an example. Suppose a spam filter marks 10 emails as a spam, but only 8 are truly spam, which means in this case, the precision is 80%. Recall is the same as sensitivity, which measures the true positive rate as we have seen. Another way to assess the model is by looking at the precision and recall at the same time. And in this example, we work out the precision and recall for the cancer example. And as you see now that both of the precision and the recall are low, and we are hoping for better values for a precision and recall to say this is a good model. So far, we have seen that a precision and recall provide more insight than simple accuracy or error rate. However, analyzing two numbers can be inconvenient. That's why researchers came up with a new measure, the F measure or F1 or F score, depends how it's defined. Let's focus on the F1 definition. So the F1 score, it tries to balance precision and recall. And in this case, it's defined as the harmonic mean of precision and recall, which is 2 times precision by recall over precision plus recall. However, in some cases, precision might be more important than recall or vice versa. So there is a generic formula for it, which is the F measure with the beta parameter. We can tweak this beta parameter. If beta is greater than 1, then we give more weight for recall, which is more useful in medical diagnosis. And if beta is less than 1, this gives more weight to a precision, which is helpful in search engines. And finally, we work out the F1 measure for the cancer problem. And as you see, the F measure turned out to be 33.96. In summary, we covered a number of model evaluation measures: accuracy, error rate, sensitivity, specificity, precision, recall, and F measure.